Welcome back guys for this part. In this part we're going to categorize the force, that is conservative force and the non-conservative force. Moreover, we're going to study in details what is a conservative and a non-conservative force, and we're going to see that how this categorization of a force is related to this chapter. Let's have a look. Now, conservative and non-conservative forces. Now, as we can see that in conservative field, the work done by the force, that is the line integral, and this is what we call this as the line integral, and is independent of path followed between the 2 points. Let's consider this is, let's look at the figure. Now these are the points, the A point and the B point. Now if you talk about this, that the body is traveling from point A to B, like there are many paths that whichever path body has to follow, it can follow, right? If body is going along this path, like path 1, path 2 or path 3, so let's consider that these are the three paths along which body is following. Now what about the thing, now what is a conservative field? That means that if body is going along or traveling along path 1, and or if body is traveling along path 2 and body is traveling along path 3 going from A to B, the work done which will come out by these paths will be equal. That means what we can say, that the work done is a path independent. So this is what it is showing, that the work done from A to B, work done from A to B from path 1, work done from A to B from path 2, and work done from A to B path 3. So all these will be equal. This is what exactly it means, that it is independent of path. Now in the second, like in conservative field, the work done by the force, the line integral of the force over a closed path loop is 0. Yeah, that is obvious. If we were talking about this path, so let's consider this path. Even if body will go along one path and body will come back along path 2, the work done, since work done is equal, since work done, magnitude of work done is equal for one path going from A to B, work done, let's say work done is positive, for coming back from B to A, work done will be negative. So for the total work done will be 0 for a loop. So this is what exactly this is showing, that work done line integral will be 0 and body is going from A to B and coming out from B to A along this path. So therefore this will comes out to be 0 if we are going to add going from path 1 and coming from path 2. If we are going to add these things, the work done will comes out to be 0. Now the conservative force, so this type of force we call this as the conservative force. The example for this is the electrostatic force, gravitational force that we have studied, that is the mg, that is the gravitational force. Now the elastic force, magnetic force, etc., all the central forces are the conservative in nature. Now this is an example, that if a body of mass m, its mass m, body of mass m lifted to a height h, this is height given, distance between A and B, from a ground level by a different path, this is shown in figure, okay. So work done by a different path, okay, work done through different path is the work done by the external force, and this external force is doing work against the gravity, against the mg force. So therefore if we talk about the case 1, it will be simply mgh, because going from A to B, so if this is height h, so it will be simply mgh. Now it will be plus mgh, because we are finding it out the work done by the external force. That means what the man is applying, or what is the force which we are providing to that block from going from A to B. That means we're going to apply, if we have to lift a block, we're only going to apply mg force, because mg force will going to act in the downward direction. So therefore if we have to lift the block, we have to apply equal amount of force mg in the upward direction. So therefore if body is going from A to B, so we are applying mg in the upward direction, and one more thing is that displacement is also along the upward direction. So what we can say, so it will be a cos 0, because angle between the two will comes out to be 0, so cos 0 will be 1, and therefore hence the positive work. So therefore it will be mgh. Now the second case for the work done 2, it will be mgh, it's h sine theta, and this will comes out to be mgh. Again this will comes out to be mgh, and we have already done these kinds of situation in the previous parts. But the thing is that for the third case, it is mgh1. This is h1 actually. So these are the staircase, and body is moving along the staircase. So this is actually the h1. This is h1, this is h2. Now if body will go from this point, let's say a to a dash, or let's say a dash to a double dash. If body will move from a dash to a double dash, and mg force, and we are applying mg force in the upward direction, so therefore what it will be, displacement will be up in the upward direction, and the mg will also be in the upward direction. So therefore what we can say, that positive work, or simply mgh1. But for this case, going from a double dash to a triple dash, like coming from this point, so for this mg will be in this direction, and displacement will be along this direction, so hence cos 90. So therefore no need to include this path going from a double dash to a triple dash. So therefore it will going to add simply h1, h2, h3 will going to get added simply. So this is what exactly it is. So h1 plus h2 plus h3, they'll going to add simply. So we're going to get mgh. Hence for the fourth case, this is the situation. A is going from B, and this. So therefore the variable force will going to act, and we call this as the work done will be integration f dx, and this we have already done. This will again comes out to be mgh. So therefore hence we can say that for all these paths the answer will comes out to be mgh. Now further, if the body is brought back to its initial position A, similar amount of work energy is released from the system. It means that work done AB is equals to mgh. Okay, this we have found that work done AB is equals to mgh. Hence the net work done against the gravity, now this is the against the gravity over a round strip is 0, because when we'll take the body from point B to point A, what we'll going to do, again mg, again also we're going to apply mg in the upward direction. Now but for this case, when body is coming downwards or coming back from point B to A, its displacement will be in this direction. So therefore 1 cos 180 and minus 1. So therefore it will be mgh plus minus of mgh. This will comes out to be 0. And so therefore what we can say, that what is the conclusion? Conclusion is the gravitation force is a conservative in nature. That means what we got, that work done net over a closed path is 0. So therefore what we can say, that gravitation force is a conservative force. Now what about the non-conservative? Now a force is said to be non-conservative if work done by or against the force in moving a body from one position to another depends upon the path. That means depend, and these two positions are for completely cycle work done can never be 0. Okay, if you don't have the conservative force, that means you have the non-conservative. Non-conservative means if for the closed path work done will not comes out to be 0. That means it will be a path dependent. So example for this is a frictional force, viscous force, air drag. So as we can see that if the body is moved from, let's consider that if body will going to move along this path and there is a friction between the ground and the block, if body will going to move in this direction, friction will automatically going to oppose this motion and will going to act opposite to in this direction. Now if we say that the body is moving, same body is moving in this direction, friction will automatically will going to change its direction by this. So therefore the friction is a path dependent and depends upon, and it is as a non-conservative force. Now further, if a body is moved from point A to point B on a rough table, the work done against frictional force shall depend on the length of the path between A and B, and not only on the position A and B. So work done will be mu s mg, and because we know frictional force is equals to mu n, and this will comes out to be mu mg. As there is no motion along the vertical direction, so normal will be equals to mg, and we will get work done from going from A to B, that will be mu mgs. Now further, if the body is brought back to initial position, work has to be done against the frictional force, which always opposes the motion. Hence the net work done against the friction over a round trip is not zero. So therefore this we have discussed in the block and the friction. I have shown it to you here that friction will automatically going to change its direction. So therefore what we can say that the work net will be work AB plus work BA, and these two work will going to add, and you will going to get this as 2 mu mgs, that is not equals to 0. So therefore what we can say that friction is a non-conservative force. Now let's look at the example. A particle in xy plane from 0 0 to AA is acted upon a force, that is F is equals to, let's write this force, that this is equals to K y square I cap plus x square j cap, this much newtons, where K is the constant and x and y are the coordinates in meters. Find the work done by this force if the particle moves along two straight lines, first from 0 to 0 to 0 0 to A0, and then from A0 to AA, and part B is along a single straight line. Okay, what exactly is the figure? Let's first talk about the part A. Now what exactly is the figure? This is the actual figure, that body will going to move along this path, and after that it will have to move along this path, and this is the straight line, and this straight line at this point is A comma A, and this point denotes A comma 0, and this point denotes 0 comma 0. So from where we have to move for the case 1, this is, let's say this is path 1, this is 2, and this is 3. So for case 1, so it has to move from 0 0 to A0, like from point A, let's say this is point B, and then from A0 to AA, that let's consider this as the point as C. So it has to follow this for part A. And for the second part it has to move along AC, something like this. So we have to check it out whether we are getting the equal or whether it is a conservative or non-conservative. So therefore let's check it out. This is the force. Let's write it down that what exactly is the force. Force is, now for the part A, force is equals to K y square I cap plus x square j cap. newtons. So since it is a variable force, so work done will be along this path will be work done for the first going from 0 0, or going from A to B, 0 0 to A 0. Now we can apply the formula F dot d r or F dot ds, where dr or dr represent dx I cap, since it has the motion along the plane or along the coordinate x and y, so it will be dx I cap plus dy j cap. Now for the first case, this can be written as y square I cap plus x square j cap dot dx I cap plus dy j cap. So this we can write this as y square dx plus x square dy. This is what we'll get the work done. Now for the work done, this is the general work done we are going to get. Let's take it as 1. Now work done, now let's find it out what will be the work done going from point A to B, that means from 0 0 to A0. Okay, if we look at the coordinate 0 0 to A0, x is changing from 0 to A. But if we talk about the y is not changing. Initial y is 0 and it is not changing. Final also it is 0. So what we can say that the change in y or dy is equals to 0. So therefore what we can write this as since dy is 0 and y is also 0. So therefore what we will get, work done by 1 will be equals to y has the value 0, so it will be 0 dx plus 0 into x square. So this is what we are going to get this as 0. So work done going from A to B comes out to be 0. Now if we talk about the second one, that is going from B to C. For this we have the coordinate a comma 0 to a comma a. So what we can say that for this dx will be 0 because initially x is a, finally also x equal to a. So we can say that dx is equals to 0. That means x is not changing, and dy is y is changing from 0 to a. So we cannot say about dy. So what we are going to get, work done for second will be equals to integration y square dx, which is 0, plus x equals to a, so this will be a square dy, and dy, so let's not, because y is changing, so we cannot write anything to dy, so that means we have to integrate along dy. Okay, we forgot something, that k was also there with the force, k was also there, so k will be here, k will be here, and k will be here also. So this will comes out to be ka square dy. So the limit for dy, for the how y is changing, it is going from 0 to a, so this will comes out to be ka cube. So therefore what we can say, work done going from a to b and b to c, this will comes out to be w for the 1 plus w2, so this will comes out to be ka cube. So therefore work done going from A to C along B is coming out to be Ka cube. So let's take it as equation number 1. Now let's find it out along the straight line. So when we go for the straight line, that is part B, that is we have to find out the work done along the straight line. So along the straight line, work is the coordinates are changing from 0 0 to a comma A. Since this is the line, straight line 0, 0, point A, and this point is C, A comma A. Now, if we'll find it out the slope will comes out to be 45 degree. Angle with the horizontal will comes out to be 45 degree. That means this is the line x equals to y, or else we can write dx is equals to dy. So let's write it down. What is the work done? Work done will remains the same. It is k y square dx plus x square dy. So therefore, what we can write this as k, since y is equals to x, this line is y or x equals to y or y equals to x. So what we can write this as x square dx plus x square dx. So this will comes out to be 2k integration x square dx. So let's take the limits from x is going from 0 to a. So this will comes out to be x cube by 3 with 2k, which is multiplied outside with the limits 0 to a. Now so this will comes out to be total work done going from a to b. This will comes out to be 2k a cube divided by 3. So by this thing we can say that the work done going along a straight line, what we can say is that if we make the figure 0, 0, a comma a and a comma 0. Now work done along going from this point a, b and c. Work done along this a to b, b to c is ka cube, but work done along this path is 2k a cube divided by 3. So that means this is not the example of conservative force. Else it is showing the example of a non-conservative force, because we are moving from a to c. Because as we are moving from a to c, directly we are getting 2a cube divided by 3, and we are moving from a to b, we are getting, or going from a to c via b, we are getting ka cube. So this is what exactly it is showing, that work done by these along these paths are not equal, hence non-conservative. So guys, in this part we have learned about the conservative and the non-conservative force, and moreover we have seen that work done when it is a conservative force for a complete loop comes out to be 0, and for non-conservative force it comes out to be a non-zero. Now we're going to proceed towards the next part, so stay tuned for that.